Okay, so we are picking up where we left off last week. Last week we were talking about the states of matter, right? We talked about plasma and liquid and gas and solids and Einstein boson states, right? And so now we're moving on. And the first thing we're going to do is we're going to watch this little video. And then once we get through these slides, we're going to take the quiz. I posted the link to the quiz in the chat box, so everyone should be able to see it. Now, I want everyone joined to it by the time we get to it, so make sure that you're opening it up in the background. So we're going to watch this video, and then we're going to answer some questions. All right, so what we saw in the video was a glacier, right? That's what this silver thing is. It's a glacier. And you saw how snow coming down was sticking to the glacier. So, how do you think glaciers form? And how does it relate to the topic of today's lesson?
I think glacier form is like water, but it's in a solid form. Solid form, like it is large mass of ice are moving slowly.
Very good. All right. So we're going to watch a little video that explains it a little bit better.
Glaciers are huge masses of ice that cover the basement rock. They are found only in regions where snow cover is permanent, that is, at the poles and at high altitude. At low temperatures, snow does not melt. It accumulates and is compacted into ice. This gradual metamorphosis, which can take several decades, results in the formation of an enormous mass of ice, several dozen meters thick, a glacier. Propelled by its own weight, a mountain glacier may become detached from the rock wall and slide downward. It slowly flows into the valley like a river of ice. As it descends, the glacier picks up rocks and debris, which accumulate in the form of mounds called moraines. If the climate warms, the glacier melts. We say that it recedes. It leaves behind a profoundly eroded landscape composed of wide, flat-bottomed valleys and many lakes.
So that explained it a little better, probably. So now that we've watched that short video on how glaciers form, explain it in your own words, how it's relevant to what we were talking about with states of matter.
Me, teacher.
Yes, you.
Like what I say again, a glacier form is like a large amount of ice that moves slowly.
All right. So glaciers are relevant to what we learned about the different states of the matter because a glacier covers several different states, doesn't it? It starts off as a gas in its gas form, right? It's water in its gas form in the air. And then it turns into snow, right? So it turns from gaseous liquid and it consolidates into snow. And then the snow falls and it hits the ground and it never melts because it's too cold there. And then it just snows some more and it snows some more. And it turns from this light, fluffy snow, it gets compacted, right? It gets compacted into a very, very dense solid ice. And the ice gets thicker and thicker because it never melts. Okay? So that's how glaciers relate to what we were learning about the different states of matter. It is showing you how the states interact with each other and how you can see it in the real world, right? All right, so I'm going to skip this part. What are examples of how state changes in matter are significant in the real world? And why is it important to learn how matter can be changed?
Example, like the ice cup melt to liquid.
Yes, that's one of them. So an ice cup, or ice in a cup will change into a liquid if it's left out, right? And then if you leave it out longer and you don't touch it, the water will eventually evaporate. So you can see all three different states in its naturally occurring. So ice, water in its solid form, and then you get water, which is its liquid form, and then it evaporates into its gas form. Very good. All right. What about Lana? Lana, tell me about an example of the state change in the real world.
The ice cream, I have tried to make it, and it turned from liquid to solid.
All right. Yes, that is one example. Not exactly what I was looking for, but that works. So the main difference in structures of each state of matter is what?
I think the volume of the particle.
You think it's the volume of the particles?
Yeah.
All right. Kian, which state of matter is being referenced in this picture? There's a great deal of space between the particles. It has no definite volume or shape. If unconfined, its particles will spread out indefinitely. Which state of matter does this talk about?
Okay, see again. Oh, I think it is black. It is gas.
Gas, all right. What state of matter is this talking about? Particles are packed tightly together. There's low kinetic energy. It has definite shape and volume. Which state of matter is it talking about?
I think it's gas.
You think that's gas? Particles packed tightly together, low kinetic energy, definite shape and volume. You think that's gas?
I have different idea.
All right, what's your idea?
I think it's solid.
Yes, it's a solid. Very good. All right. It is the most common state of matter in the universe. Stars are essentially superheated balls of this state of matter. Yanfeng, what do you think the answer is?
Can you say image?
Most common state of matter in the universe. Stars are essentially superheated balls of this state of matter.
I think this is plasma.
Plasma, very good. All right. Tom, the particles are close to each other, held by weak intermolecular attraction. It has a definite volume, but an indefinite shape. What is it?
I think it's liquid.
Liquid. Good. There is almost no kinetic energy being transferred from one atom to another, so the atoms begin to clump together. This state of matter is used to study quantum mechanics on a macroscopic level. Lan Na, what is this state of matter?
E.
Yes, the Bose-Einstein condensates. Remember, we've already talked about solids, liquids, gas, and plasma. So by default, it could only be the Bose-Einstein condensate. You could still join after it's been started. So there's 12 questions. You have until the end of class to take this quiz. All right, based on the overall accuracy of the quiz with only 50% right now, you guys need to be doing the studying on your own. You're not going to get much out of this if you're not doing the studying and the homework on your own time. Time is up. For those 3 of you who haven't finished,